And we'll start.
Great.
Looks like we got people flowing in already, 2 minutes
Yep.
early. This is wonderful.
Okay, I guess we're ready to go whenever 10:30 hits, huh?
Yeah, we got 2 minutes to go.
Okay.
We're about a fourth of the normal population.
Hugh, what's the prospect at RTB for getting people back in the office and things going back to normal? Is there any like goal date, or is everything still just waiting?
Well, we've got about half of our employees that come to the office because, I mean, we have a big building and people can be in their offices with their doors closed. We're not letting the public in yet. So, and likewise, when we have our books shipped out, we just put them outside for UPS to pick up. So, and, we are abiding by all the government regulations. We require all of our employees to wear masks when they're outside of their office.
Mm-hmm.
But I'm predominantly working at home, and saving the transportation time. It's actually making me. I mean, both Kathy and I are finding we're getting more work done as a result.
Isn't it amazing how much time you use driving around?
Right. Well, we're fairly close to the office, and we do go to the office once in a while. We just feel it's important to make contact with human beings.
Sure. Yeah, they do hang around that place every once in a while.
Yeah, they do. So,
well, it looks like
okay,
we're
I'll
up
let you
at,
guys get started.
All right, we're at 10:30 a.m. What I'm going to do is I'm going to start us off with questions from last week. So we'll get right into that. Juven from the Netherlands asks, Dr. Ross, are you planning to write a book on parenting according to biblical principles?
Well, I'm not sure I was all that good of a parent, so I know. I mean, I'm not planning to write a book on parenting, mainly because, and this is, I think, is a message for all of us. We really need to stick to what is our bailiwick. I mean, there's so many other outstanding Christian authors writing on parenting that it's something I'm not going to get into. Neither am I going to write any novels. That's not going to happen. I mean, I think I really need to stick to what I can do well. And there's not that many people that are able to write on the kind of science faith issues that we write about at Reasons to Believe. And so I'm actually telling Jeff and Fuzz as well, look, stick to this because, I mean, this is what people come to us for. So, well, I can tell you a funny story. I was at this best-selling authors luncheon, and there was 30 of us who were, quote, best-selling authors. And that was at a time when the Creator and the Cosmos hit the bestseller list. But what was really funny, I was sitting around all these tables, and I noticed I was the only man there. There was 29 ladies, and I was the only guy. And so it was like, what's wrong with the men that they're not writing best-selling books? And then these ladies started to ask me when I was going to come out with my next romance novel. And I realized I was the only author there that didn't have a book that was a romance novel. So that kind of indicates, what really sells and what doesn't.
Okay.
But I'm not writing any romance novels. And my wife would have a fit if I wrote a romance novel.
Okay, well, how about this? A question from Chris Thompson from Anchorage, Alaska. Before Martin Luther died, he lectured on Genesis, adopting a science and grace approach. He was well versed in science and astronomy as it existed in his time. Why is it so hard for current pastors to learn to adopt this approach, which you obviously encourage in your ministry?
Well, we do. And, it's interesting. If you were to go back about 150 to 200 years, cosmology was dominated by men of the cloth. I mean, particularly in Britain. I mean, the people that are really doing the work there We're people that were vicars in the Anglican Church, and the Catholic Church likewise has had a long tradition of being involved in astronomical research. Even to this day, the Vatican maintains an observatory in Rome and sponsors about 2 astronomy conferences per year. But I remember taking a short course from the cosmologist. Oh, this goes back ways. He's passed away. Engelbert was his name. And he said, there was a time when our discipline was dominated by the reverends, but we got rid of them with a straightforward application of tensor calculus. And he was joking, but I think there's some truth to that. In order for a man of the cloth to be able to do astrophysical research and cosmology in particular, they have to take a lot of advanced mathematics. And so, unfortunately, we don't see the integration. I do know a few pastors that, like me, are also astronomers, but you can count them on one hand.
Okay. Megan Rogstad asks, can you give examples of how science points to the existence of higher dimensions? And how does that strengthen the case for the existence of the God of the Bible?
Well, it's a theme I take up in my book of Beyond the Cosmos. It's now in the 3rd edition, and you can get a free chapter at reasons.org/Ross. And in that book, I make the point that as cosmologists and particle physicists have engaged one another, and I was on the faculty at Caltech at one time as a research fellow there, and Caltech was a place that really gave birth to this idea of extra dimensionality, because what they determined was that in order to fully integrate particle physics with cosmology, there had to be extra very tiny dimensions of space. And there was a team at Caltech, and by the way, it involved a lot of people who are believers. In fact, one of them, Gerald Cleaver, actually, I talked to him quite extensively as I was writing the book Beyond the Cosmos. His name is in the acknowledgments there. He's now I think, the chairman of the physics department at Baylor University. He was part of that team, and basically said for a 10-year period, we wrestled with, okay, in order to get this fully integrated, do we need an 8-dimensional universe, a 9-dimensional universe, all the way up to a 26-dimensional universe? And it took a decade, but they finally recognized the way it works is if you got 6 very tiny dimensions that accompany the 3 large dimensions. Now, a lot of people think that this is string theory. String theory is one of the many particle physics theories that falls under this 9-spatial dimensional context, but it's not the only one. It is possible that string theory is not the answer to how we integrate particle physics with cosmology, but I think what is reasonably secure, whatever answer it is, you're going to need those 6 tiny space dimensions to accompany the 3 large ones. And just very quickly, the story falls under unified field theory, where the universe starts off nearly infinitely hot. That's a core of Big Bang cosmology. As the universe expands, it gets colder and colder. As it gets colder and colder, you see the fundamental force of physics. The universe started off with one force of physics, and then it splits into 2 as it cools. And as it cools more, it splits into 3, and then it splits into 4. When it splits into 2, when the force of gravity separates out from the other 3 forces of physics, that's when six of the 9 dimensions of space stop expanding. So all 9 dimensions of space expand together from the cosmic creation event, but at 10 to the minus 43 seconds after the cosmic creation event, 6 of those 9 dimensions stop expanding. So today, those 6 are no bigger than what they were when the universe was 10 to the minus 43 seconds old. The cross section of each of those 6 tiny dimensions is 20 orders of magnitude smaller than the diameter of an electron, which basically explains why people didn't notice it until they tried to integrate particle physics with cosmology. Anybody who wants more details, it's in the book. As far as experimental proof for all this, particle accelerators have been able to duplicate the separation and the unification of the last two forces of physics. That was done in the 1970s. I think the first particle accelerator was the one outside of Chicago, the Fermi Lab. They were the ones that were able to demonstrate that if we actually generate the heat density conditions of the universe when it was very young, we can actually unify the electromagnetic force with the weak nuclear force. And we now have particle accelerators that get us partway towards the unification of the electroweak force with a strong nuclear force. So that's the experimental evidence that sustains the unified field theory, which sustains this idea that there are extra dimensions. And theologically, it means we are worshiping a God who's got the power to create 9 dimensions of space and a dimension of time.
Thank you. Christine Murphy asks about the keeping Saturday as a Sabbath. She says that God wrote his laws on my heart in the 4th commandment to remember the Sabbath and keep it holy and preserve it for God is important to her. And she wants to know whether you believe the same thing as keeping Saturday as a Sabbath, or what your perspective is.
Well, I certainly believe in the Sabbath. I mean, it is in the 10 Commandments. I think to answer her question, we need to look at all the passages in the Bible that pertain to the Sabbath. And in particular, you'll see Paul addressing the Sabbath in the book of Romans. And he's making the point that the principle of the Sabbath is taking one day out of your 7-day work week to stop the work that you do to support yourself and your family, and instead do the work of focusing on the most important issues of life. And I think in the 21st century, that's a problem with much of humanity. We're so occupied in our day-to-day work and in taking care of our families, and we're so distracted by the high technology civilization in which we live. There's just so much entertainment everywhere you go that we do not take regular time to focus on the most important issues of life. But what you see in Romans 14, and this is in the context where Paul is addressing what we should eat, what we should not eat, but with respect to the Sabbath, he's making the point. The principle, one day out of 7. It doesn't matter if your Sabbath is a Thursday or a Friday or a Saturday or a Sunday. It doesn't matter what day of the week it is. And for that matter, trying to trace our calendar and link it with the calendar of Abraham and Moses, that leads to a lot of difficulties. I know people think it can be done. As an astronomer, I don't think that's possible, that we can link it. So we really don't know which day of the week relative to our day of the week Moses was celebrating. But the whole point is one day out of 7. And Paul in Romans 14 basically says, you've got the freedom. In fact, I've been invited to speak on this subject at Seventh-day Adventist universities, and basically making the point, if you're a Seventh-day Adventist pastor, your Sabbath is not going to be Sunday. That's your work day. What you need to do is take a day outside of Saturday and make that your Sabbath. And because the principle of Sabbath, you stop your regular work and focus on the most important issues of life. And I've noticed that the Seventh-day Adventist professors and pastors, they go along with that, saying, yes, in our case, our Sabbath isn't going to be Saturday. It's got to be another day of the week because, our whole employment is basically, building our message for the Saturday and the doing ministry. And, Saturday is a work day. So hopefully that helps. And again, one day out of 7. And, people say, well, I kind of take pieces of a day. make sure you got at least long chunks, but make sure about 1/7 of your week is focusing on the most important issues of life.
Thank you. Tinny asks, is there evidence for what the shape of the universe is? And if the shape is curved, does that mean if we travel in a straight line in the universe, we'd end up in the same place, like traveling in a straight line on the surface of the Earth?
Well, she's making a good point, or he. I'm not sure what Tinny is, male or female. Uh, but that's something astronomers have been focused on for decades, is trying to measure the shape of the universe. Um, if the universe has an inflation event, and we now got good measurements to prove beyond any shadow of doubt that an early inflation event indeed did take place, such an inflation event will flatten the geometry of the universe. Will it make it perfectly flat? It could, but it might not. There are a lot of inflationary models that don't require the universe to be perfectly flat. What I can share with you is that our measurements, based on the very best maps of the cosmic microwave background radiation, show that the universe is flat to 4 places of the decimal. But likewise, inflationary Big Bang cosmology tells us it'll be impossible to prove that the universe is flat beyond 5 places of the decimal, which means we'll never be able to prove whether or not it's perfectly flat. But for example, if it's spherically shaped as opposed to hyperbolically shaped, that does mean that you could travel and come back to where you start, kind of like what happens here on planet Earth. And the analogy there is, Earth is a 3-dimensional sphere, but we humans live on the 2-dimensional surface. And if you travel in a straight line, you'll eventually get back to where you started because we have a closed surface. And likewise with the universe, it's 4 dimensions, length, width, height, and time. The time dimension behaves geometrically like a 4th space dimension, and all the galaxies and stars, all the matter and energy is distributed on the 3-dimensional surface of the 4-dimensional universe. And so yes, if it was a closed geometry, kind of like a spherically shaped system, if you travel in a straight line, you do wind up back where you started. If it's hyperbolic, then yeah, you can keep going and you'll never come back. Same thing with this flat. Keep going, you'll never come back.
We still have more questions, but I know you wanted to get on with your webinar. You had a couple of other things you wanted to talk about. Is this a good time for you to move into your other presentation?
Okay, and like always, we'll aim to have about 30 minutes of teaching, where I'll be showing you my keynote presentation, and then we'll have an extended time for Q&A. And also, we're going to have a time to have some fellowship with one another, engage one another through a meeting. That's not possible in a webinar, and you say, well, why don't you launch a meeting? We used to do that, but then if you make it public, you invite Zoom bombers. So the webinar is secure, but I'm going to give you a URL so when we do leave the webinar, we can go into a meeting. However, today is an extraordinary day. 2 days ago, this paper got published in Science Advances. And incidentally, that's put out by the American Association for the Advancement of Sciences. They put out the premier science journal that's called Science. And if you want to get those journal articles, you can get the abstract for free, but the paper you got to pay for. Science Advances is different in the sense that it's online. It's not available in print. I had to, copy this, but they make all the papers that are published available free to the public. So this is a paper you can read from cover to cover. And by the way, I'd encourage you to do that because it is quite lay accessible. Unlike a lot of other papers published in Science Advances, it's not loaded with a ton of equations, and you can read the text. And I was surprised how lay friendly and readable it is. And the title is When the Moon Had a Magnetosphere, and was published on October 14th. Oh, that's 4 days ago now. Okay. And I'm going to be writing a blog on it. So it's going to show up at reasons.org under my Today's New Reason to Believe blog. I'll be submitting that to our editorial team tomorrow, but it probably won't come out till sometime in November. But I'm going to give you a sneak peek right now. So what I'm going to do is share screen. Oh, come on. Where's that? Here it is. Oh, Safari just did an upgrade. I'm not able to find the file I want. Come on, let's see what we can do here. Just give me a moment here. See if this will help. Nope. Well, let me give this a go and see what happens. Okay, new feature here. Okay. Again, I apologize. It's making me search through my whole computer to find the documents. Wasn't expecting this to be that difficult. Okay, that's not going to work. This should work. Finally, I got my desktop. Okay. Now then. Nope. What I want is grayed out, but I think there's a workaround here. Again, my apologies. Here we go. Let's see if this works. Aha. Oh, now it's taking time to open. Okay, back up. Come on. Back up some more. Okay. Ah, here we go. Okay, Mark and Ross, are you able to see my first slide here?
No, I don't see anything, Hugh. It's just
Okay,
screen.
all right. I'm kind of stuck here. Let me stop share and see if I can get back in again. I'm so sorry about this. Okay, let me see if one of these will work. Hmm. And this, okay. I think we're going to get somewhere.
Yeah, we see it now.
Fantastic. Apparently, the new Zoom upgrade required me to wanted me to do a total restart, but I found a workaround, so I didn't have to do that. So anyway, we got that fixed. Hopefully that'll be fixed from now on. Okay, I'm just reminding you of the URL you're going to need when we go into our meeting. So it's the same we used in the previous weeks, and I'll show this again later. But let me jump into this new discovery. Okay, first of all, this is what the flaring activity history of the sun looks like from the time the sun formed through to the present era, and what it's going to be like in the future. That blue dotted line there shows you what it is right now, making the point that we human beings are living on the earth when the sun has minimal flaring activity. And that flaring activity is also correlated with the X-ray and gamma ray radiation coming out of the sun. Now, the y-axis there is logarithmic. I mean, if you go to when the sun had maximal flaring activity shortly after it formed, that's more than 100,000 times more flaring activity than we have today, between 100,000 and 1,000,000 times. Likewise, the X-ray and gamma ray radiation was that more intense. And what the four researchers headed up by the planetary astronomer James Green was making the point in this paper is that the young sun was pouring out such intense radiation. And incidentally, we're blessed to be orbiting our star, the sun. If you go with a star more massive than the sun or less massive than the sun, then you're going to have even more intense flaring activity and X-ray and gamma radiation. So we're orbiting the best possible sun. But even this best possible star that we're orbiting, when the sun is young, you got this very intense radiation and a very powerful solar wind coming out. And the authors of this paper, published a few days ago, made the point that the calculations we now have on the intensity of the solar wind are such. Oh, by the way, just give me a moment. My cat is trapped here in the room and definitely wants out. I'll get her out. I'll be right back. Okay, here you go. Come on, out you go. Sorry for that other interruption. She has a habit of getting really loud if I don't pay attention to her, but now that she's exited the room, we should be fine. But basically, these authors are making a point that when you look at the intensity of the solar wind, when you go back, say, 4 billion years ago, it's so intense, it should have stripped all the water and the atmosphere away from the Earth. And clearly that didn't happen. And what protects us from having our atmosphere and our water dissipated to interplanetary space is our planet Earth has a magnetic field, a strong magnetic field, thanks to the interior heat flow in our planet and thanks to the amount of long-lived radiometric elements, isotopes in our planet's interior. It's got this strong, long-lasting magnetic field. But these authors make the point that the Earth's magnetic field would have been weaker 4 billion years ago than it is today. It's stronger today because the interior of the Earth is cooled enough where we got a solid inner core, and outside of that, we have a liquid outer core. But 4 billion years ago, the entire core was liquid, and that would actually give you a weaker magnetic field, a less stable magnetic field. So as you got a weaker magnetic field, and you got a much more powerful solar wind coming out of the sun, that should have significantly stripped away our atmosphere and our hydrosphere, the oceans on the surface of the Earth. Matter of fact, some models for the history of the Earth actually claim that's what happened, that in the first billion years, Earth lost, say, 70% of the water that it had after the late Benin event. But it's very difficult to discern how it is that the Earth could have began with that much water and that thick of an atmosphere. All the models we have for the early history of the Earth tell us that the atmosphere of the Earth and the amount of water on the surface of the Earth may have been a little bit more than we have today, but not a factor of 4 or 5 or 10 times more. And so these four authors basically say, we think we've got an answer to this conundrum, and the answer is the moon. And they basically refer to a paper also published in Science Advances, published a little earlier in this year 2020. And what was interesting about the paper they cited, it basically takes an analysis of the Apollo lunar rocks that were returned to Earth. And when I read the paper, it's like, you mean it took almost 50 years after we collected these lunar rocks to do the necessary analysis? Well, the point is, I had to wait that long to get the kind of sophisticated instruments they needed to actually analyze these lunar rocks. And basically, what they discovered, even back after the Apollo 12 was the first time they returned lunar rocks where they had a magnetometer on the surface of the moon, able to measure the magnetic field. And that's when they discovered that if the moon has a magnetic field, it's 10,000 times weaker than the field of the Earth. And shortly after that, as they return more rocks, they discern, well, the magnetic field we see in these lunar surface rocks is a remnant field. It's basically a memory of a past field. There's no magnetic field on the moon today. There is no dynamo in its interior. However, what we see in these ancient lunar rocks is basically a memory, a signature of a past magnetic field. But not until the beginning of 2020 did we have the instrumentation to analyze those rocks and determine what the magnetic field of the moon was 3 billion years ago, 3.5 billion years ago, 4 billion years ago, as far back as 4.2 billion years ago. But what they discovered is between 3.5 and 4.2 billion years ago, the moon's magnetic field was between about 20, between about 0.2 and 1 Gauss, between about 20 and 100 microtesla. And that's roughly comparable to the Earth's magnetic field. Today, the Earth's magnetic field, depending where you are, its weakest is in the country of Paraguay, where it only has 23 microtesla or 0.23 Gauss. And where it is strongest is halfway between Tasmania and Antarctica, and that's where it comes in at 0.65 Gauss. And so the paper basically raises the interesting point that if you go back 4 billion years ago, the moon's surface magnetic field was about the same as the Earth's surface magnetic field at that time. Because the Earth is a bigger body, that actually adds up to a stronger magnetosphere for the Earth than you get for the moon. And then the authors also cite some research done by a Russian astronomer where he actually models the past history of the Earth-Moon system. And all astronomers are aware that the moon is spiraling away from the Earth, and we can measure that with some precision and trace that back accurately, at least a couple of billion years, realizing that the moon had to be much closer to the Earth 2 billion years ago than it is today. The real challenge is modeling it back to 4 and 4.5 billion years ago. But a Russian astronomer by the name of Zarkov has actually done that. His paper originally was published in Russian, but it's now been translated. And the authors cite his work, basically making the point, if you're to go back 3.9 billion years ago, the moon was about 21 Earth radii away from the Earth. And if you were to go back 4 billion years ago, it was 18 Earth radii. So it was more than a factor 3 closer to the Earth 3.94 billion years ago than it is today. And so this caught the attention of James Green and his team. And basically, they made the point that, it's possible that 3.9, 4.0, 4.2 billion years ago, the magnetospheres of the moon and the Earth were coupled. And so they went to work developing some computer calculations. And I'm going to show you. I mean, this is in their paper, but the diagrams they had there are quite complex. And so I've taken it out of their paper. In fact, you can go to their paper. There's a place where you can click and get a high resolution JPEG of their figures. So I did that. I imported it and basically reworked it slightly so that everything was to scale. And so this next slide will actually show you to scale what the Earth-Moon coupled dipole field will look like. And to help you understand this, to the left, we got the sun. And so this shows you what the magnetosphere of the Earth-Moon system would look like when the moon is lined up between the Earth and the sun, and where the dipoles of the magnet inside the Earth and inside the moon are aligned. And so you've got the solar wind, a powerful solar wind. Keep in mind the solar wind was much stronger back then. This powerful solar wind is blowing against the magnetospheres of this Earth-Moon system. And basically you see this bow wave out there showing how the solar wind would push against the magnetosphere of the Earth-Moon system. But basically shows you that the combination of the Earth-Moon system in this particular configuration would protect the atmosphere of the Earth and the ocean of the Earth from being sputtered away. And if you were to take the moon's magnetosphere out of this, you will not get a strong enough magnetosphere about the Earth to protect the atmosphere and the oceans of the Earth from being sputtered away by solar radiation. But the combination of the two indeed gives you the adequate protection. And in this model, we don't need to have the Earth starting off, say, with 10 times as much atmosphere or water than it's got today, something that none of the models for the formation of the Earth or the Earth-Moon system would actually allow. And this next slide shows you what the magnetospheres look like when the Earth is between the moon and the sun. And so you do get a different shape for the magnetosphere. But in this case as well, the magnetosphere of the moon contributes sufficiently to the coupled magnetosphere to prevent the powerful solar wind from sputtering away the atmosphere and the ocean of the Earth. Now, this is where you got the dipoles, the magnetic dipoles of both the Earth and the moon aligned. And the researchers said, well, let's do the opposite. Let's see what it looks like when the dipoles are anti-aligned. So for example, we got a north-south here for the Earth, and then you got a north-south for the moon that's aligned this way. So when you got them anti-aligned, you do get a different shape for the magnetosphere. But once again, we see the moon contributing sufficiently to the coupled magnetosphere that the Earth's oceans and atmosphere are protected from being sputtered away by the powerful solar wind. And in this case, we're looking at the situation where the moon is between the Earth and the sun. And this shows you where the dipoles are anti-aligned, where the Earth is between the sun and the moon. And again, you get a different shape, but in both cases, you see the moon's magnetosphere contributing sufficiently to the coupled magnetosphere to protect. And so they're basically making the point, the researchers, we now have an answer to how it is the present day Earth has as much air in its atmosphere and water on its surface as it does. And they also made the point, if it had any less, there'd be no possibility for advanced life on planet Earth. We need an atmosphere of a certain pressure for lungs to be able to efficiently function and for there to be enough oxygen for animals to be able to exist and thrive on the Earth. And likewise, the amount of surface water in the Earth is fine-tuned. Make it any less, you're not going to have sufficient water being subducted into the deep interior of the Earth. By the way, it's necessary just to get an amount of oxygen that we need and also to sustain the plate tectonic activity so that you've got continents building at a rate that compensates for the rate at which the continents are being eroded away, make sure the nutrients are being efficiently recycled. And the researchers end their paper by basically saying, this is a habitability requirement. Excuse me. Sorry about that. They close their paper off by saying, this is a habitability requirement for any planet to be able to host anything more than microbes for a brief period of time. They're going to need to have this small planet orbited by a giant moon, orbiting relatively closely, where the moon also has a strong magnetic field. Now, the moon's magnetic field quickly dissipated once you get past 3.5 billion years ago. By 3.1 billion years ago, it had dropped by about a factor of 15 to 20 times. And today there's no magnetic field at all. However, the moon's magnetic field was sustained at a strong enough level to couple with the Earth's magnetic field throughout the first billion years of the Earth-Moon system. And if we were to go back to this diagram right here, what we notice is once you get past that first billion years, the flaring activity level is sufficiently low that the Earth is no longer at risk of having its atmosphere sputtered away by solar radiation or having its ocean sputtered away by solar radiation. But the point that the authors are making, for a planet to have life on it for a significant period of time, you're going to need to have a planet-moon system virtually identical to the Earth-Moon system in order to provide the necessary protection during the first billion years of that planet. And basically makes the point that unless you've got a moon that's about the size our moon is with the interior composition, and the only way you're going to have a moon with a powerful magnetic field for the first billion years of its history if indeed the moon formed through a planet about the size of Mars, or maybe 30% bigger than Mars, merging with the Earth when the Earth was about 95 million years old, and where that planet Theia had an internal composition similar to the internal composition of the Earth, which means that the moon would have begun with an iron core, not nowhere near as big as what the Earth had, but sufficient, and with the heat of accretion as a result of the formation of the merging of the Theia Earth system, proto-Earth system, to make the Earth and the moon. The heat, interior heat in the early history of the moon and its interior composition would indeed provide it with a magnetic field. But the authors make the point, unless a moon forms just like our moon formed, it's not going to have a strong enough magnetic field to be able to protect the nascent Earth from the intense solar wind. And so the moon has to form just the way it did. And I've written papers at reasons.org making the point that as astronomers have looked at how the moon forms, they've been quite disturbed by all the fine tuning that's necessary to get the Earth-Moon system the way that it is. And the British journal Nature basically sponsored an issue several years ago where they said, let's see if we can come up with more sophisticated models for the Earth-Moon system where we don't have this extraordinary degree of fine tuning. And basically, the team of 5 lunar origin researchers indeed came up with more sophisticated models, but every one of the models actually had more fine tuning, not less fine tuning, which caused one of the researchers to write in Nature, all of this fine tuning is causing us philosophical disquiet. Philosophical disquiet because it really looks like this is something that requires the hand of a supernatural being to get all the fine tuning just right. But this paper published in Science Advances is basically making the point. Unless you got a fine-tuned event, just like the Earth-Moon system, the moon-forming event happening at just the right time, orbiting the just right star at the just right distance, you're not going to get this coupled magnetosphere, which is essential to protect the atmosphere of the planet and the oceans on that planet so that future advanced life would be possible. And so they're basically saying, as we begin to look for planets outside of the solar system that can be possible sites where life exists, if we're talking about something more than bacteria existing for a few years, where we actually got life existing for a significant period of time, this is another habitability requirement. But it's such an extraordinary habitability requirement that we would be, and by the way, they didn't put this in the paper. I'm the one that's saying this. This habitability requirement is so extraordinary, so exceptionally fine-tuned, there's no way we're going to have another habitable planet in the universe unless there's a super intelligent, supernatural being that's fine-tuning another planetary system, just like he fine-tuned our planetary system. Because without this coupled magnetosphere, you're not going to have long-lasting life on a planet. So that's kind of the bottom line here. And I wanted you to be the first to know about this. I mean, this is what we do at Reasons to Believe. We read these research papers, and the authors were basically making the scientific points. They didn't draw any philosophical, theological conclusions, but they did state explicitly in their paper, this is a new habitability requirement that must be taken into account in our search for planets beyond the solar system that could be candidates for life. But it's such a restrictive requirement, it basically says, if there is no God, then we are alone. And matter of fact, if you look carefully enough at our own planet, we wouldn't be here unless there is a God, given the extraordinary degree of a fine tuning. So with that, I'm going to stop the share feature and dive into our lesson. So I just wanted you to be aware of this, and you're welcome to ask questions on it. Let me see if I can, yeah, here we go. So, And how much time did I use? I actually used up the time. I'm going to stop here. If you don't mind, we'll pick what I will share with you. What we're going to do next week is I'm going to take you through all the New Testament epistle passages that talk about suffering. And they're from James, they're from Peter, they're from Paul. And, Peter especially and Paul write extensively about suffering, how it's a necessary factor given the way the universe is designed, but how we can explicitly benefit from the suffering. And basically makes the point that this suffering that God takes us through is a gift. God intends us to use it as a special gift to display his glory, and basically makes the point, if we apply the suffering that God takes us through in the way that he intends, it's going to bring us overflowing joy. And a lot of people looked at these texts and say, well, yeah, I get that. It's going to give us overflowing joy in the new creation. Well, that's certainly true. These authors make that point, but they're also making the point you're going to see some of it right now. So we're going to actually look at those texts. And what I'm going to do is take next week, we're going to go through all the passages quickly. And then we're going to go back and one at a time, I'm going to put you in small groups where we get to discuss exactly what this passage is teaching about suffering, and in particular, how we can put it, how we can apply it in our lives right now, and how we're going to actually experience joy and glory in this life. And so I really want you to focus on how we can actually enjoy and experience the benefits right now. And it's kind of Paul and Peter are talking about. God gives us a foretaste of what we're going to be experiencing in the new creation. But having been a pastor for 4 decades, my experiences as Christians have never had that foretaste. So we'll be talking about how we can get that. And I think a good way is to break us up into small groups. But I'm also going to bring the small groups back together so we can discuss as a big group what we discovered. So that's a preview of what we're going to do next week. But Mark and Ross, let's take some questions and we'll go from there.
Okay, I still have a few questions left over from last time, so let me get at those, then I'll give it over to Ross. So Doug from Monrovia says, decay is necessary for digestion. How could decay not exist before the fall of man? And what do young earth believers say about that? Death and decay, are they linked? Are they not?
They are linked, and that is certainly a major challenge to young earth creationist theology, is that we need this pervasive law of decay just to be able to digest the food that the plants provide for us. And likewise, you're not going to have stars shining without this pervasive law of decay. You need a relatively high rate of decay for stars to shine so that we can live here on planet Earth, and for plants to be able to produce food through photosynthesis, and for us to be able to take advantage of that photosynthetic food so that we can thrive as well. And as I've engaged young earth creationist scientists on this, I say, well, we recognize this. What we're really saying is that before the fall of Adam, thermodynamics was different. Thermodynamics is still in play, but that the level of entropy was much, much lower. But if that's the case, you can't get stars shining. You can't have photosynthesis work. You can't have animals digesting that food. And so we need to realize the thermodynamics, the entropy must be fine-tuned. It can't be different before the fall than after the fall. And I've run into young earth creationists saying, well, maybe other laws of physics were altered in some way so that we wouldn't have physical death happening. Because, yeah, if you got this high rate of decay, you will have physical death accompanying that. And how I've engaged young earth creationists on this is basically take them to the Bible. One thing I've realized about young earth creationists, they have a very high respect for the Bible. They may not appreciate what God has revealed in the book of nature, but they certainly take the Bible very seriously, and basically show them how the Bible teaches that the laws of physics will not change from the moment that God created the universe until the full number of human beings that God intends to redeem have been redeemed. Romans 8:23, which means that at the fall of Adam or at the flood, there was no change in the laws of physics. And actually, if you look into the young earth creationist literature, if there is no change in the laws of physics at the fall of Adam and or the fall or the flood of Noah, uh, their model collapses. All young earth creationist models, all global flood models critically depend on radically altered laws of physics. We're not talking adjustments of, say, 1%. They need to make adjustments of about a factor of 1 billion or 1 trillion times in order to make their interpretation of the Bible work. And I've had quite a bit of success doing that, mainly because I'm basically appealing to my young earth friends without any reference to the book of nature, just focusing on what the book of scripture teaches. And the principle there is it's not enough to take the creation texts in the Bible literally. We also must take them consistently. And I found that many of my young earth creationist friends, including those that are leaders of major young earth organizations, they really haven't taken the time to integrate all the biblical creation texts. We're talking over 1,500 passages. We're talking over about 24 lengthy texts in the Bible that deal with the subject of creation. As one of my colleagues at Reasons to Believe has joked, not all the answers are in Genesis. There are 65 other books, and we need to help people integrate across all 66 books. And if I could just say one more thing, what I really appreciated about the research done by the International Council of Biblical Inerrancy, when they dealt with controversial issues like divorce and remarriage, finances, the age of the earth, they applied this principle. Let's look at every single relevant biblical text, not just the ones that people will toss back and forth in their debates. Let's look at all of them. And I think that's a good hermeneutic approach. Before you come down on a doctrinal point, make sure you read carefully through all 66 books and integrate all the relevant passages.
Thank you. Stephen Posta from Spring, Texas asks, what was the purpose of the transfiguration? Since no photographs existed of Moses or Elijah, how did Peter, James, and John even know who they were, Moses and Elijah?
Well, we don't have a lot of detail in the gospel accounts on the transfiguration. Having read those texts, I think it was basically Jesus working with the three leaders of his 12 disciples, making the point that there's more going on than what we see in this universe. He wanted them to experience the realm beyond this universe. And so they go up to this high mountain. There's been much discussion as to which mountain that was. A lot of people think it was Mount Tabor. I've been to Mount Tabor. It's only 2,000 feet above the Jezreel plain. And the text says a high mountain. I personally think it was probably Mount Hermon. That's the highest mountain in the area. It's 10,000 feet high. But that's immaterial. The text just says he took him up to a high mountain. And on top of that mountain, Jesus was transfigured. And what that means is he was basically taken from this realm into the realm beyond. And there he was joined by Moses and Elijah. And they were both radiating light. I mean, Jesus was radiating light. Moses and Elijah were radiating light. And you see this in Revelation, that the new creation, everything is going to be radiating light. And apparently it was a dazzling light, so much that it really stunned the three disciples that were observing what was going on there, James, John, and Peter. And you say, how did they recognize that it was Elijah and Moses? Mainly because they were students of the Old Testament. When they saw these two human figures with Jesus, they realized from understanding the Old Testament, there's only two candidates. What we know about Elijah, well, there's actually three candidates. You've got Enoch, who was taken from earth while he was still alive to heaven. So he did not physically die. And then you've got Moses, and he was up on this mountain. And what the text tells us is that he died there, but his body was never found or recovered. So somehow he was taken bodily from this realm into the new realm. And Elisha, his protege, got to witness Elijah being taken alive from this planet up into the heavenly realm. And, you know, Jewish scholars at that time said, okay, that there was going to be a special future role for Elijah and Moses, and how Moses represented the law and Elijah represented the prophets. And so here you've got these two humans, one representing the law of the Old Testament, the other representing the prophetic books. And so they're there with Jesus. And apparently, Moses and Elijah were having a conversation with Jesus. And maybe that's how James, John, and Peter recognized who they were, just by the conversation that they were having. And if you read the book of Revelation, two witnesses come from heaven to the earth before the return of Christ. And, you know, a lot of people say, well, it's got to be Elijah and Moses. One represents the law, one represents the prophets. They're going to come back to earth and call people to repent before the Lord returns. And if you're aware of Jewish theology, you know, today we have Jews who celebrate this Passover. They always have an empty chair at the Passover table, and that's a chair for Elijah. They're expecting Elijah to come back. You actually see this in the Gospels. People were speculating that John the Baptist was Elijah. He was the one who was coming back. But evidently, God's got some future role and purpose for Elijah and for Moses. And so I think that persuaded the three. You know, there's a realm beyond this realm. And I think that really helped them when they were facing threats of death. I think you really see that in the book of Acts. These men were incredibly bold in the face of extreme persecution, but they had seen the Lord in a dimensional realm beyond this one. They saw Moses, they saw Elijah. I think that experience had a profound impact on them.
Thank you. We have the last question from last week, which is from Stephen Posta from Spring, Texas. In a recently published paper in the Astrophysical Journal, Harvard University astrophysicist Avi Loeb, L-O-E-B, purports that an equal mass stellar companion to the sun formed about 1,000 AUs from the sun. He claims that this increased the likelihood of forming the objects in the Oort cloud and the capturing of Planet 9. Can you please opine on this?
Yes, Abraham Loeb at Harvard, he loves to write these kinds of papers. I've cited them frequently in the articles that I've written. This is his latest. And, you know, he likes to ask the what if questions and, you know, trying to say, okay, we have this Oort cloud. How did it? Maybe our sun robbed a bunch of comets and asteroids from another planet. And he's really addressing the question, why is it that the Oort cloud is so much bigger than the other four asteroid and comet belts? And so this is why he's making the speculation, well, maybe our star stole a bunch from another star. Now, as we astronomers look out at other stars, we do see in some of the nearby ones that some of them really do have the equivalent of our Oort cloud. So apparently Oort clouds are fairly common. And just to kind of give you context, we refer to the Oort cloud as that comet/asteroid belt that exists between about 1 trillion to 10 trillion miles away from the Earth. So it's the most distant, but it's by far the biggest of the asteroid and comet belts. And you know, people have critiqued this years ago, saying, "Well, how come we haven't seen any of these objects?" The answer is because of how far away they are. But now we're actually seeing some of the more nearby Oort cloud objects, and it affirms that indeed there has to be a heavily populated belt of comets and asteroids out there, and for no other reason to feed the inner belts, because if there's a perturbation, we see several of them can be pushed into the interior part of the solar system. So yeah, it's an interesting paper, but just keep in mind when Abraham writes, he likes to ask these what if questions, and sometimes he gets it right, and sometimes he says, well, you know what, it was a good try. So, and that's kind of the fun part of being a research scientist, is just having the freedom to ask these what if questions. Matter of fact, this paper I was referring to, that was basically the birth of the research, saying, you know, we got this puzzle here. How can we solve it? Abraham Loeb is basically saying, this is an apparent puzzle. By the way, a lot of astronomers say we don't need this kind of interaction to explain the Oort cloud, just because of looking at the models that explain how you get the 8 planets. They say you're going to wind up with a giant Oort cloud. The people at the Nice group think that they can explain the Oort cloud without any such kind of reference. However, there is good evidence that our solar system did form inside a dense cluster of stars, in which case there would have been this kind of opportunity.
Well, thank you, Hugh. Mark, thank you. Doug Combe here in Monrovia has a good question. He says, how do you feel about Christians celebrating Halloween? And I would like to add to that related question about Christians who can enjoy, for example, the Harry Potter film series.
Yeah, interesting question. I don't really write about that kind of stuff, but my colleague, Ken Samples, does. And, you know, Ken basically addresses the question that a lot of Christians have this idea that we should never syncretize with pagan holidays. But if you actually look at church history, and Ken Samples is a really good student of church history, what Christians have done is taken the holidays of unbelievers and basically co-opted them and transformed them into a meaningful Christian celebration. So yes, there was a pagan Easter celebration, and you know, Christians basically co-opted that and made that a celebration of the resurrection of Jesus. Likewise, they co-opted the Christmas celebration, saying, hey, this is a holiday that's celebrated by the pagans out there. Let's take the same holiday and transform it where we celebrate the birth of Christ. And basically, they were looking at this as an evangelistic tool. Hey, they're already celebrating these things. Let's give them a means by which they can actually hear and understand the gospel and begin to celebrate it in a Christian context rather than a pagan context. And Ken Samples also makes the point that, you know, these great Reformation hymns and hymns of the Victorian era, that many of those have their origin in bar rooms, where, you know, there'd be a pub, they'd be singing these songs, and what Christians would do is they would take the melody, change the words, so basically using the same captivating music that's there, but putting it in a Christian context and using it as a way to teach doctrine. And Ken makes the point, this is a powerful way of communicating the gospel before the population became completely literate. You know, if you've got people attending church where say only half of them know how to read and write, singing these easy to memorize songs with a melody that makes it easier to maintain the memory, this can be a powerful tool for teaching doctrine. So when he addresses Halloween, Ken says, is there a way that we can take this pagan holiday and put it into a Christian context? And makes the point that the reformers already did that with All Saints Day, basically making November 1st a time to celebrate the contributions of saints that have gone before us, kind of like Remembrance Day, but putting it in to a Christian context. And but he also raises a concern that unbelievers are basically making Halloween an excuse to, well, to put it bluntly, to engage in ungodly revelry. And so he's concerned that Halloween is not what it was 100 years ago, where you got kids putting on costumes, going out and doing trick or treat. Basically, we're now seeing people using this as an opportunity to engage in seances, the occult, and to engage in sexual immorality and drunkenness. So he says, that's something that we need to speak out about, and basically say, let's make this a safe time for kids to celebrate. And also be careful what costumes you have for your children. And, I'm always concerned about the amount of candy that's distributed and consumed. Uh, Young children don't need all that sugar in their system. So, if people come to our home, I got broccoli ferrets there. Uh, in fact, we don't get that many kids coming by anymore because of that. But I also notice I'm encouraging, and Ken does this in his blog, saying, okay, if your kids want to celebrate Halloween and go door to door and get treats, go with them so that you can be there to protect them, because not every home are they going to get a pleasant experience. And so be sure you're there to protect them. And if they start asking questions about the occult, etc., you're there to help them put it into a Christian context. So that's my take on it. I do like what Ken offers. And but I know there's a debate in this issue.
Thank you, Hugh. Fred Tusing, I think that's the right pronunciation, says, what about fractional dimensions? Do they exist or are they discrete?
Okay, fractional dimensions. There's been some speculation on that, but yeah, there's not a lot of enthusiasm in the community of mathematicians or physicists for this. Is that these dimensions, in order to fit with any kind of consistent physics, now it is true that you can quantize space and time, but you're not basically fractionating the dimension. You still have dimensions that go out to infinity, and you can do things on certain parts of it. So, yeah, I mean, and there's still some debate going on too. Okay, we have this universe with 3 large dimensions of space, 1 dimension of time, and 6 tiny dimensions of space. But is it possible that there's a 4th large dimension of space that we're not seeing? So you got things like M theory in cosmology, where they're speculating about these things. The journal, Physics Letters B, is basically a journal dedicated to sponsor these kinds of out-of-the-box speculations. I call them out of the box because there's really no way that we can perform experiments or observations to prove whether this is real. But from a biblical perspective, we know that there's dimensional realms beyond ours. After all, God created a distinct species of intelligent life, angels. And angels are not constrained by the space-time dimensions of our universe. They have a distinct realm. Evidently, they can come into our dimensional realm and they can leave. We humans are designed in such a way that until our life passes in this earth, we're constrained to the space-time dimensions of this universe. Now, if there's a follow-up, I'll be happy to deal with it, but hopefully that will be adequate.
Thank you, Hugh. Ryan is with us from Pennsylvania. He says, a friend showed me a preprint paper where they have possibly seen glycine amino acid on Venus. I know there is a lot of research toward the Venus phosphine. So is this to be expected in the absence of life in Venus's wild atmosphere?
Yeah, I've seen that preprint. In fact, I made a brief comment about it on my Twitter page. And if all of you are not aware, what I do on my Twitter page is alert you to scientific research papers that have some significance for the Christian faith. And I'll always give you a link so you can go straight to the paper. In this case, however, it's in a preprint stage, although it has been accepted for publication, so it will be published. But all it's available right now is a preprint. That's not such a bad thing, because one of the things about preprints, the site is arxiv.org. That's where they have all the preprints, and you can read the entire preprint without charge. So you can go there and look at the paper yourself. And I've been getting a lot of questions about this, so it's apparently getting some notoriety. But glycine is the simplest of the amino acids. It has only 10 atoms. Uh, we have yet to find glycine in an interstellar molecular cloud, but we already know the chemistry in these interstellar molecular clouds will produce glycine. The problem is the chemistry in these clouds also work to destroy the glycine that is produced, which is why we've not found glycine in these interstellar molecular clouds at the parts per million level. But I anticipate that relatively soon they're going to be announcing the discovery of glycine in interstellar molecular clouds, but it's probably going to be at the level of a few parts per billion. And the phosphine that was discovered in the upper clouds of Venus, it was at the level of 20, maximum 40 parts per billion. So we're not talking a lot of phosphine. And phosphine is a relatively simple molecule. So I wasn't at all surprised that it was discovered. Now, there are people pointing out that typically phosphine is a byproduct of life. There are ways you can get phosphine without life, but usually, I mean, especially here on Earth, it's always from life. However, I've written before, and you'll actually see an article on our website making the point that beyond planet Earth, the most life-friendly site in our solar system are the upper clouds of Venus. It's beastly hot on the surface of Venus, but as you go up in the atmosphere, the temperature gets cooler and cooler, and at a certain altitude, you'll have a temperature appropriate for life. Now, as I say, it's the most life-friendly place outside of the solar system. It's still not that friendly. You're talking a lot of sulfur molecules up there. So the environment is really not appropriate for viable life, but it is a place where the remains of life could be preserved. And given how close Venus is to Earth, meteors striking the Earth, if they're big enough, will export Earth's soil into interplanetary space. So we anticipate there will be quite a bit of that Earth material in the upper clouds of Venus. And yeah, it would be enough to explain most, if not all, of the phosphine we see there. But even easier to discover will be the glycine. Now, as I looked at that preprint, I also noticed the amount of glycine they claim to have found in the upper atmosphere of Venus was at a very low abundance level. And so, given that's the simplest of the amino acids, that abundance level was well in line with what we would expect if indeed that glycine is there because of the remains of Earth life that's been transported there. But I also can see how the chemistry, because there's some, you've got a lot of carbon dioxide, carbon monoxide, you got sulfur, you got nitrous oxides in the upper atmosphere of Venus. If you've got ammonia and you got nitrous oxides and you got carbon dioxide, you will get these glycine forming. So I would expect, even without life, you're going to get glycine in the upper atmosphere of Venus at a low abundance level. And don't be surprised. I expect in the next couple of years, we're going to get a lot of announcements of discoveries of the simpler building blocks of life molecules. Why? Because now astronomers have the technology to discover these things at parts per billion. A few years ago, if it was below a part per million, they couldn't discover it. But now they got the instrumentation to find things at abundance levels of a few parts per billion. They're going to find glycine. They're going to find probably 5 more amino acids. They're going to find at least one of the nucleobases. They're going to find the ribose, the sugar that's necessary to join together amino acids to make, or pardon me, the nucleobases to make DNA and RNA. These things will be discovered, but at parts per billion, it's of no value to a naturalistic origin of life model. Naturalistic origin of life models require that these simple building blocks be available at much higher abundances. So don't look at this as support for an origin of life model, even if the researchers announcing it say it is. Always look at the abundance level. But I expect we're going to be seeing him only at parts per billion. And by the way, I wrote an article many years ago on our reasons.org website saying, you know, in meteorites, they have found 6 of the bioactive amino acids. The other 14 will probably never be found because of how extraordinarily difficult it is to make them, especially tryptophan. And so researchers have said the basic amino acids, of which tryptophan is probably the one most people have heard about, it's such a complex chemical pathway to make it, it's not going to be found. And if you don't have tryptophan, you're not going to have life. And my colleague Fazal Rana has just finished a book where he's made the point there are hundreds of amino acids out there in the natural realm. The only amino acids out of those 100 that will work for life are the 20 we see in life systems. So he says we need some kind of extraordinary process that is able to select out of the several hundred amino acids the only 20 that are going to make possible the existence of life. That's in his forthcoming book. It'll be out in a little less than a year.
Thank you, Hugh. David Edwards has a question that refers back to your PowerPoint earlier this morning. He says, does anti-aligned mean that the lines of flux from the Earth and Moon are in opposite directions?
No, it's simply a reference to the fact that the magnet that's generating the magnetosphere would be aligned with the magnet in the Earth. So the Moon's magnet would be aligned with the Earth's magnet. And then they also showed what happens when they're misaligned. But basically, the authors are making the point. It doesn't matter about the orientation of the magnet inside the Earth and the Moon. No matter what the orientation is, you'll get a coupled magnetic field, a magnetosphere, that is adequate to protect the Earth's water and the Earth's atmosphere. Because that was a question they had. Would it make a difference if we were to change the orientation of the magnet? And what you notice is it makes some difference, but it's a relatively minor difference. Notice in all 4 figures that I showed you, you do get a coupled magnetosphere that couples in such a way as to provide adequate protection. That's the main point of the paper.
Thank you, Hugh. Keith Wilson asks, how did Venus retain its atmosphere at the time you speak about of the young sun?
That's a good question. And Venus is the norm. Earth is the exception. I mean, in terms of planet formation, the more massive the planet, the denser the planet, and the more distant it is from its host star, the thicker will be its atmosphere. And so you got Mercury, which has just a thin argon atmosphere, and it has a thin atmosphere because of how close it is to the sun. I mean, basically, the heat and light being radiated by the sun is going to blow away, dissipate any atmosphere that Mercury had initially. And then likewise, it's simply not massive enough and dense enough for its gravity to be able to hang on to light molecules. It's got sufficient density and mass that it can retain argon. Argon has an atomic weight of 40. And so argon is a sufficiently massive molecule that even the gravity of Mercury can retain it in spite of how close Mercury is to the sun. But once you get out to Venus, Venus is a much more massive planet, has a much stronger surface gravity. And because of its strong surface gravity and its distance from the sun, it's able to retain a thick atmosphere. Now, Earth has an even stronger surface gravity and is even more distant from the sun than Venus is. And of all the planets in our solar system, Earth is the one that sticks out like a sore thumb. It's got an atmosphere way too thin, given its surface gravity and given its distance from the sun. And this tells us astronomers that when the Earth first formed, its atmosphere was about 200 times thicker than the atmosphere it has today. So how to wind up with a thin atmosphere? The moon forming event was a big factor. That moon forming event stripped away most of Earth's primordial atmosphere and primordial water. We also realized Earth started off with a whole lot more surface water than it's got today. The moon forming event stripped that down. And likewise, you got other events that made a lesser contribution. But for light to be possible, you have to be orbiting a planet that's a certain distance from its star, has to be a special kind of star. And you need the planet to have a certain surface gravity, but it also needs to have a thin atmosphere and a thin layer of water. And it's thanks to Earth's extraordinary formation history that all those conditions are met. So Venus is the norm. It's got exactly the atmosphere we would expect.
Thank you, Hugh. David Edwards has a question regarding your old Revelation study. He says in the first session that you say there is a 3 times, I think it's what he's saying, longer translation of Revelation 1 that you handed out. Is that still available?
Okay, I'm trying to remember. I mean, I taught that class 35 years ago, so and apparently I handed out a translation of Revelation.
Yeah, he says in the very first session, you said that there is a longer translation of Revelation 1 and that you handed it out.
Ah, okay. Yeah, I do remember that now because we spent quite a bit of time in the opening chapter because that kind of sets the interpretive theme for the rest of the book. There's symbols defined in Revelation 1 that are referred to later in the book of Revelation. So what I did in that particular set of episodes is I went to lexicons. I went to the Theological Word Book of the Old Testament, the Amplified Bible, went to the original Greek, and basically tried to provide something a little more expanded than what you would get, say, in the Amplified Bible. Basically giving you in depth the Greek word definitions. Because after all, the translators have got to take a single Greek word and translate it into a single English word. And so what I was kind of doing was giving you a full lexical definition for all the different words that we see there used in Revelation 1. Yeah, I produced that document. I'd have to go through my files to see if I still have it. I do know that at reasons.org in our warehouse, they retain a lot of the papers that I wrote that I handed out in the class. But I doubt that we have a complete set. And so, but I'll have to go through my file and see if I can dig that out. So yeah, thank you for jogging my memory. I forgot about doing that. And then maybe I need to go, if we can't find it, I'll see if I can find some time to redo it, but that's the source of it.
Thanks, Hugh. John Belling is with us from London. He says that's a great presentation on the fine-tuning of the magnetic fields of the moon and the Earth to protect the Earth for the solar flares. He says he has a question regarding water. Why did the hydrogen molecule come together with the oxygen molecule and eventually fill 71% of the Earth's surface with water? I know water is an essential ingredient for life forms to survive, but I am wondering why God created so much of it. Could we have an Earth with, say, 50% land and 50% water?
Okay, good question. And let's see, I think I got a book back here. Yeah, Peter Ward, he's at the University of Washington, and he's a paleontologist, but he's also quite well versed in geology and geophysics. He wrote a book a number of years ago. By the way, I've gotten to know the man. We did a debate in the state of Washington many years ago. He's an atheist, but we got along well. And he's actually published a lot of material that we've been able to use at Reasons to Believe to further extend the fine tuning of the earth as an argument for God. He's aware we're doing that. And he actually co-authored a book with, I'm trying to think of the guy, Don Brownlee. And Don Brownlee refers to himself as an agnostic, but as I look at what he's written, I think he's at least a deist. And the two of them actually consulted with a Christian astronomer there at the University of Washington, and they produced the book Rare Earth. And that book's been cited frequently by unbelieving astronomers, basically making the point that maybe bacteria could exist on another planet, but not complex life. And so Peter Ward had a contribution to that, but he also makes the point that if you look at the history of the Earth, we see that Earth started off as nothing but water on its surface. And then thanks to plate tectonics, we actually see that the continents begin to cover more and more of the surface of the Earth, where today it covers 29% of the surface of the Earth. And he makes the point that is still ongoing. Yes, the continents are shrinking as a result of erosion, but the continents are being built up as a result of plate tectonics. And over the past 2 billion years, the rate of continental growth has just been very slightly greater than the rate of continental erosion. So if you were to go back about 2.3 billion years ago, 27% of the Earth's surface was covered by continents. Today it's 29%, and that's increasing. And Peter Ward's argument is when it hits 30%, that will be the end of advanced life on planet Earth. He basically makes the point that the ratio of water coverage to land coverage is something that must be fine-tuned in order to make sure that we got the right bacteria on the face of the Earth. And he's basically written, when we get to 30%, we're going to find bacteria that release hydrogen sulfide to the atmosphere will begin to greatly increase. That's a deadly poisonous gas for almost all animal life. And so, he's basically said that inevitably will happen. We will get to 30%, but it's not going to happen anytime in the near future. That's still millions of years off, given that it's taken, 2.2 billion years to go from 27% up to 29%. But Peter's point is it will go up to 30. And when it gets to 30, it won't be game over for the bacteria, but it'll certainly be game over for us human beings. We talked about this over a meal when we were doing the debate. I said, well, that's very interesting, Peter, but the sun is getting brighter. And that's going to do us in long before the continents hit 30%.
Thank you, Hugh. Hugh Van has a really interesting question. He's in the Netherlands. He says, what is the biblical and spiritual significance of the experience of deja vu?
Okay, interesting question. And we've all had those experiences where, as what's that baseball player says, is deja vu all over again. Where we say, hey, this looks remarkably like what I think I've experienced in the past. And, sometimes it's just a random event that seems very similar to what we experienced in the past, but it feels like deja vu, like, hey, I've been here before, I experienced this before. But when you begin to analyze it in detail, you say, well, it was similar, but it wasn't exact. But there are people who claim to have had exact repeat experiences. And this is particularly cited by Hindu theologians as evidence that reincarnation actually is true. The fact that there are humans running around saying, I've had experiences that I know didn't happen in my current life, but it's exactly what I'm seeing right now. Therefore, it must have been something I experienced in a previous life. Or people claim to have memories from a previous life. And we need to be aware that we are not the only intelligent beings that God has created. He's also created angels. And we're told in the Bible that there is a war between the evil angels and the righteous angels. And these evil angels are highly motivated to try to persuade us human beings that we have a second chance. It tells us in Hebrews chapter 9, verse 27 and 28, it's given unto us human beings once to die and then the judgment. And so we're not going to be reincarnated. where we get a second chance. But I think we can understand why demons, fallen angels, the evil angels, would be motivated to persuade us, hey, don't worry about this life. You're going to get another chance. In fact, you're going to get thousands of chances. You're going to be reincarnated again and again and again. And therefore, don't get too stressed out about trying to achieve all the righteousness you need to achieve in this life, and hence motivate people not to take this life seriously, to stop obeying the Sabbath that we talked about earlier. And you say, can demons really implant into our consciousness a fake memory of a past experience, or something where we read in a history book of what Napoleon experienced and say, hey, I had that memory in a dream once. I must be the reincarnated Napoleon. Well, if you open up yourself to the occult, to trying to seek powers beyond what God has granted us in this human realm, demons can take advantage of that. And if you give them permission, they can implant these kinds of false memories into your consciousness. So, as it says in 1 John, test the spirits to see where they're coming from. If you have a strange dream or a strange vision, you need to put the spirits to the test. Now, having said that, it's not always the case, and we get that kind of a quote memory or vision that is always from a fallen angel. A friend of ours, Gary Habermas, he's a professor at Liberty University, and we've had a lot of good conversations and contact with him. He's best known for his research on the historical evidence for the resurrection of Jesus from the dead, but he's also very interested in these visions that many Christians have when a loved one dies. And from his research, he says it seems to happen that about 35% of the time when a Christian dies, his close relatives or friends will often have a short vision a day or two or three after that person has passed away, basically reassuring them, don't worry about me, I'm in the right place. Because sometimes we worry about, okay, my friend or relative passed away. Did they really go to be with the Lord in heaven? Or what I saw in their life gives me some doubt. And so there's those reassurances. And so those are cases where a righteous angel can give that quick reassurance. And what was interesting in having that conversation with Gary, he says, it's interesting is that the visions are always about 5 or 6 seconds long. They're not long, they're short. And it's just a quick reassurance. And it's always an angel taking the form of the Christian who passed away and said, don't worry about me. I'm fine. I'm in the right place. I'll see you in the future when it's your turn to graduate from this life into the next life.
Thank you, Hugh. Mark Durham, our friend here in LA, says, regarding the coupled magnetospheres of Moon and Earth, what generated the magnetosphere of the Moon 4 billion years ago?
Well, the moon forming event where you got this planet Theia colliding with the proto-Earth. And we now know that Theia was about 11 to 15% of the mass of the present Earth. So a little bit bigger than Mars. That merger of Theia with the proto-Earth would have made the Earth a little larger, basically enriched the Earth with more heavy radioactive isotopes and also more iron. And so that explains why Earth has such a strong, steady magnetic field. But to a lesser degree, the same thing happened with the moon. It too wound up with an iron core, albeit much smaller than the iron core in the Earth. And because of the tremendous heat of accretion involved in the merger of Theia with the Earth, its innards would have been quite warm enough that with that iron core, it would have generated a magnetic field. Now, the total strength of the magnetic field would be nowhere near the total strength of the primordial Earth, but given that the moon is so much smaller than the Earth, the surface magnetic field of the moon 4 billion years ago would have been approximately the same as the surface magnetic field of the Earth. And as I mentioned when we talked about it, 4 billion years ago, the Earth's magnetic field would not have been as strong as it is today. It would have been just a little bit weaker, mainly because at that time, the interior of the Earth was so warm, there would be no solid inner core.
Thank you, Hugh. Scott Hankinson asks, is it true that Mars has no radiation protection?
Today, that is true. Mars has no magnetic field and has a very thin atmosphere and really has no protection from cosmic radiation or radiation from the sun. And so the idea that you could have astronauts running around on the surface of the moon, that's not realistic. And, I wrote an article in today's New Reason to Believe. I think it got posted about a year ago. You can find it by just saying, go into the search engine, look for gut-wrenching space travel. Basically makes a point. Once you get outside the magnetosphere of the Earth, you will be exposed to deadly solar radiation and deadly cosmic radiation, and particularly the deadly cosmic radiation over the space of as short as 3 months will largely destroy your intestinal tract. And therefore, the idea that we could send humans to Mars, where they could do useful things on the surface of Mars, that's not realistic. Mars does not have a magnetosphere. And so unless you go underground, you're going to be exposed to that deadly cosmic radiation. And people have speculated, maybe we could send a spaceship to Mars where we protect the people on board that spaceship with a magnetosphere that protects us here on planet Earth. The problem is, it's not even conceivable that we could build a magnetosphere, a magnetic bottle around a spaceship that's big enough to house human beings. We can't even build a small magnetic bottle to basically condense hydrogen to a sufficient density where we can get fusion operating. I mean, we have yet to build a fusion reactor where you get more energy out than we put in to build that magnetic bottle. These magnetic bottles are really tiny. To make them bigger is technologically, at this point, impossible. In fact, a number of physicists said the only way that we could make a magnetosphere that would be stable enough and powerful enough to protect men and women on a journey through interplanetary or interstellar space is to make a spaceship as massive as the Earth, because then you can use the gravity of the spaceship to retain that magnetosphere. But now you're looking at something very expensive.
Great, Hugh, thank you. Juven from the Netherlands has another good question. He says, in the book of Revelation, John was shown the vision of an apocalyptic future. How could John, from the 1st century, explain something about the future which would have been so hard for him to understand? You think John could have seen skyscrapers or fighter jets?
It's possible. I mean, you see that in the book of Elijah, you see that in the book of Daniel. Elijah and Daniel likewise had visions similar to what John was experiencing of what the future would be like. And we did that. We went through the Revelation class, basically went back to the book of Ezekiel and the book of Daniel and made note of the fact that these prophets, just like John, really struggled to describe what they were seeing in their vision. And notice you see in the book of Daniel, for example, where Daniel's saying to the angel, look, I'm really confused by what I'm seeing here. And basically the angel says, we don't want you to describe this. This is not for you to release to the public. It's for you alone. And so he was basically told, look, this is for your own personal edification, but don't record it. But even what he recorded was a real challenge for him to do. So yeah, he was struggling, and people speculated. I mean, there's a number of books on the book of Revelation making the point that maybe what John was seeing in his vision was the equivalent of fighter aircraft and tanks. I mean, it does talk about, you know, horse-like things spitting fire out, and maybe people speculate maybe that's a reference to tanks. Who knows? Aircraft, who knows? So, but yeah, it's clear he was struggling to describe. If you look at Ezekiel chapter 1 and chapter 10, it's evident that Ezekiel was trying to describe something that apparently was transdimensional. You know, this idea of wheels inside wheels are intersecting or they're moving, that really doesn't make sense if you only got 3 dimensions of space. So, yeah, I do feel that they were struggling, and therefore, I think we'd be wise not to speculate too much above what they're experiencing.
Hugh, we have 1 minute left, and we will ask a question from Karina in Mexico. She says, how does the presence of multiple small moons instead of a big one like ours, how would that affect the planet magnetosphere analysis? Can small moons give the necessary protection from the high radiation of the central star in a planetary system?
That's a good question. And, you know, I'm humbled because she is actually a planetary astronomer. I'm not. My specialty was galaxies and quasars. But, you know, the people who work on these models are basically saying in order for a moon to have a strong magnetic field, it's got to be big. If it's too small, it simply won't have sufficient iron, and it particularly won't have the accretional heat uh, and the in order to generate a magnetic field. And you know, reading this paper published in Science Advances, and I've read a number of other papers. In fact, this is all in my new book. And I have a chapter on the moon making the point how remarkable it is that the moon actually sustained a strong magnetic field until 3.1 billion years ago. It really takes remarkable fine-tuning design. It's one thing for a moon to have a magnetic field, but to sustain as strong a magnetic field that the moon had for that long of a period of time, you know, almost 1.5 billion years. That's nothing short of a miracle that we have this moon, as small as it is, with a field that's that strong. But you know, the reading I've done is the real reason why the moon has had such a strong magnetic field for such a long period of time is the moon forming event. Yeah, it really takes a merger event like what we see with Theia merging with a proto-Earth to get a moon that is able to have a magnetic field that strong for that long. But as these 4 researchers point out, this is relatively new news. It wasn't until we had this detailed analysis of all the lunar rocks brought back, we're able to actually determine with some precision just how strong magnetic field of the moon was and what happened to the moon's magnetic field from the time it formed until today. We now have a detailed record of that, but it really wasn't until January of 2020 that such a detailed record was available. And that led to a spat of papers being published trying to explain how it is that the moon could have such a strong magnetic field. But yeah, the idea of having a cluster of small moons, none of those small moons would have a magnetic field. And you'll notice that the moons that do have a magnetic field, Ganymede is the only moon in our solar system that has an undisputed magnetic field. And notice that's the biggest moon in our solar system. So yeah, you do need a significant total mass for there to be any hope of a significant magnetic field.
Well, thank you,
Okay.
Hugh. We are out of time. Do you want to close us?
Yeah, I'll close us. And yeah, we didn't break up into rooms today. I was going to do that, but I wound up taking a little more time than I thought I would need to get through that discovery. Hopefully you all enjoyed that. I was really, and I'm encouraged because I was really trying to communicate it in a way that lay people can understand. So, and from the questions, hopefully I may had some success in doing that. But next week, we'll jump straight into these passages we see in the New Testament. And frankly, I think this is a relevant time to do this. You know, this pandemic is lasting a lot longer than any of us thought it would when it first came upon us. And what I've been noticing, I've been seeing this in our church and I'm seeing it on social media. The stress of the pandemic is bringing about suffering like we have never experienced before. It's really starting to get to people. So I think these texts we're going to look at are going to have some relevance for what we're going through right now. So we'll do that next week. And I hope we'll all enjoy the discussions that we have. So let me close us in prayer. Father in heaven, thank you for this time we've had together today. Thank you for this amazing technology that allows us to engage one another in spite of this worldwide pandemic. But also we take this opportunity, Father, to pray for all the researchers. Lord, some of us know individuals at the National Institute of Health and how they're working around the clock to try to come up with a safe vaccine, an effective vaccine, and effective therapies. Thank you for the progress that's happened so far. But Father, we pray you would bless their efforts. And we look forward to the time when we can actually be free of this pandemic and be able to engage one another in significant fellowship and love relationships with one another. So, Father, help us to cope in the meantime. Help us to be creative. And Father, I pray that we would all realize that when we give our lives to Jesus Christ, from that point forward, we're never alone. So, Father, help us to look to you for that fellowship and comfort that you provide to us without even asking. Lord, make us aware of what you've provided and give us opportunities, Lord, day by day to be a messenger of sharing with others the good news of salvation through Jesus Christ with gentleness and respect. In Jesus' name, amen. So with that, let me end the meeting and we'll see all of you next week if you're able to join us.